everyone, welcome to this new episode of the Water Underground Talks, and today it's our great pleasure to welcome Professor Daniel Olago from the University of Nairobi in Kenya. So welcome, Daniel.
Thank you, Viviana.
We will start the talk today with a couple of questions for you. And the first thing that we would like to know is, how did you first develop your passion for water?
Okay, that's a good question. Well, I've been fascinated by water, I think, ever since I was young, as far as I can remember. I grew up in a place where not so far away, there was a nice small stream, and there were lots of tadpoles in it. And I liked to go and just look at the clear water and, play around in it, and stir up some mud and see how it turns, brown and murky and then clears up again. And it's been a passion that I've had ever since I was young, and I've taken it all the way through to my university education. So I'm basically a geologist, but I also do a lot of work on lakes as well. And I'm quite involved in lake management activities in the global arena.
We will look forward to hear more about your job. But then we have another question for you before your talk. According to you, how does your personality or your personal interest make you a better scientist?
Well, that's a difficult question in the sense that who is a good scientist and what actually defines a good scientist? I think, you just get better as a scientist. Let me just refer to the, groundwater aspect itself. You just get better when you really think about conserving the resource, when you're passionate about, being a good steward of it, making sure you keep it clean, making sure it's safe to drink, making sure it's safe to swim in and play in. And, I think that is basically what drives the research that I do. It is more about ensuring that this resource is available and it is really well used for humanity and also for the ecosystem at large.
Yeah, it's really important indeed. And finally, well, you already probably anticipated something, but we are curious to know which is the impact of your work, of your research out of the world of academia.
I would say it is substantial, at least within the region in which I work here in Eastern Africa, because we have generated a lot of knowledge products and data products which are being taken up by different sectors, by the governments, at national level and also at the county level, by practitioners who are incorporating some of our findings in planning, how they're going to deal with water issues in whatever way within their organizations. We have worked with communities as well and, helped them to understand more, in essence, the value for protection of a water resource and how to manage it, at a household level and beyond that. And we've also been able to give information to water utility companies, which is improving their delivery of services to the urban dwellers.
Thank you. And now we are even more curious to know more about your research. So we can move to the second part of our talks.
Thank you very much, Viviana. Let me move right away to my next slide, and I hope it will be an exciting piece of information for you from my side of the world. So what are some of the key features of the arid and semi-arid lands? These areas are characterized by high climate variability and very low or low rainfall amounts, normally less than about 400 millimeters per year. And we see also in these areas, like in the vast areas of Africa that are arid and semi-arid, that the groundwater potential is extremely variable. And it varies in space, it varies over time, it varies in quality, and it varies in quantity. And what are some of the reasons for this variation in the water quality and potential? Spatially, because the hydrogeological settings vary. We have different types of aquifers in different parts of the continent. They vary over time because we have climate variability, and particularly the variability in rainfall that occurs over short time frames, for example, in over a few days, or seasonally, or interannually, or even over decadal scale cycles. So we see that variation as well. Quality varies as well, and quality is influenced by the natural geological setting. That is one of the major factors, but also it may be influenced by human activities within the catchment areas and within the area where the aquifers are, can be directly impacted by, say, for example, pollutants from the surface. And it also varies in quantity. And the quantity is also a function of the geology. It's also a function of the climate. In this area as well, these arid and semi-arid lands, we see a huge rise in the demand for water. And the main reason for this, actually there are two reasons, is because these particular areas have rapidly growing populations now. But secondly, there are now competing interests which are coming in. For example, water for irrigation to produce food. And for example, we have many new oil and mineral discoveries in these dryland areas, and water is required for production. So that demand is also increasing. And actually a third area of demand there is related to these very fast growing urban centers in the drylands with a lot of commercial activities for which the water demand also increases. But all of this is happening against a backdrop where we have low water supply systems, poor sanitation coverage, and in some places, water-related diseases arising from using water from unprotected groundwater sources is also occurring. But these areas, and you can see the panel on the right, there is just an indication of the paucity of data, which is a major challenge that we experience in these areas. So although this particular diagram relates to water stress and it is fairly old, you can see that for large swaths of the continent, there is very little data. And for where there is data, we do see that actually all these countries are either moderately to highly stressed with regard to the water resource. So I just want to take you up to northern Kenya, where I will be presenting a little bit of the research work that we have done there. So this is what the arid and semi-arid lands look like, as you can see. Very sparse vegetation, quite sandy, and much of the water that is there is normally scooped from scoop holes in dry riverbeds. These riverbeds tend to be either ephemeral, lasting for only a few hours after the rain, or they could be seasonal, but most of them tend to be ephemeral streams. And so they store the water under the ground, and this water normally tends to be fairly clean and unpolluted. As you can see on the left photo there, the area is very dry, but it is also sparsely inhabited. On the right-hand side is the town that we're interested in looking at its groundwater resource. It's called Lodwar. And you can see that in this particular area, this town is located, actually it straddles a large river called the Turkwell River, which basically gets its waters from 300 kilometers south from the highlands of Mount Elgon. So sometimes they get floods, and the flooding destroys, infrastructure, including houses, pipelines, etc. And on the other hand, it can be as dry as we see in the photo on the left. And this town relies 100% on groundwater, which is sourced from boreholes that are dug adjacent to the river. And so from time to time, flooding episodes also destroy the installed groundwater supply system, disrupting water supplies to the town. So basically, we started our groundwater research here from a ground zero, where we had no data really on anything about the groundwater system. The practice has just been that the hydrogeologists come out with their thermometers, do a geophysical survey at a certain location, determine whether or not it has a groundwater potential, and then the drillers come in and drill. But nothing was really known about the aquifer system at large. So we started from ground zero, and here in the next slide, I show some of the information that we have been able to develop for this particular area. We have been able, if you look at the left-hand panel, to the main groundwater potential is for that area. We carried out a lot of different analysis of, in terms of research. We looked at climate parameters, we looked at hydrology, we looked at the groundwater itself, characterizing its geometry, its stratigraphy, and its extent. So we're able from that to also develop on the right-hand panel there a conceptual aquifer model. And all of these, here I'm depicting the two aspects, the water quality index, which is allowing for any development to take place in targeted areas. So in a sense, one can actually make big savings from this kind of an approach, because you can target where you are most likely to be able to get, good and safe quality water supplies. The aquifer system shows, the conceptual aquifer model shows how that entire system interacts, and therefore which particular regions, for example, would need to be protected from, say, human activities that may, introduce pollutants either directly or indirectly into the groundwater system. So this kind of information is very useful for the managers and practitioners and the community at large to be able to enhance and increase the amount of safe water supplies that they have for the rapidly growing town. Here I want to take you down to another different area, and this is a coastal sedimentary groundwater aquifer, where we have similar situations as we do in the other region that I have mentioned. The current resource estimates are basically inadequate. And the result, this is because we have inadequate aquifer characterization. Not enough work is done at the scales that are needed and to the detail that is required to determine these parameters. So we see that groundwater is being developed without an adequate understanding of the resource. And that means that all of these developments are happening without a clear understanding of the sustainability of the resource. This is actually made worse when you consider that we're looking to achieving the Sustainable Development Goals, including Sustainable Development Goal 6 for water. And also, it is made more complicated because we are in a world whose climate is changing. And with climate change, we expect to see changes in the parameters that influence the amount of water that can be stored within an aquifer system. Of course, that would be largely changes in the rainfall amounts and changes in recharge. And lastly, changes in the properties of the ground. So we are operating in an environment where we have no or not very clear groundwater protection policies, where clear management mechanisms are not in place to manage these aquifer systems, and the financing for the water sector is deficient. But one of the other things that I want to point out here is that in this particular area, there had already been discovered some high-yielding boreholes. But we went down to the ground and did things the traditional way, really walked to and fro, looking for whatever exposures we can, trying to understand the groundwater system in whatever manner that we could in a much better way, including the not only the traditional ways, but also using fairly advanced techniques. And we did, from our study, actually find out that there were two buried alluvial channels that had the potential to yield a huge amount of copious water. So normally these boreholes would yield, say, between 1 to about 50 cubic meters per hour, but the ones which we have been able to outline can yield as much as 300 cubic meters per hour. And this is all based on not just doing geophysical studies at a single spot, but taking an aerial perspective and a multi-pronged approach to understanding the aquifer system. Now to other areas which underpin this, and this is basically relates to, how do we manage this particular resource? We do have documents that have laid out very nicely, for example, the Science, Technology and Innovation Strategy for Africa 2024. I put this diagram here because it really recognizes the key role that water plays, whether it is groundwater, surface water, and the links that it has to the 6 main priorities that they are tackling for that particular period in time. So you can see that water availability is a key issue. Water quality is a key issue. The water cycle and how it is changing is important. And all of these help us to manage a lot of societal problems, like eradication of hunger, ensuring that we have food and water security, controlling disease, because a lot of diseases within the region are due to drinking water that is contaminated by pathogens, bacteria and others. And it also underpins wealth creation. Like I mentioned, when you're developing, for example, your ore and mineral resources, you need water to process those further into products that can also enhance and add value to the economy of the region. So those particular dimensions do exist, but we have another issue that also really needs to be considered. It is often said that women are better managers of water than men. And it is a question that you can argue, and it is open to debate. But we do recognize that their participation in water management is extremely important. Okay, but we recognize that it is also influenced by a number of underlying social factors, which include power relations, right from the household level to the national level, local to national politics, as well as socio-cultural norms, which may or may not allow them to really take their rightful role in the management of the water resource. So this is another aspect that we're basically incorporating into our research to really try and understand this. We have been able to, under the REACH program, to carry out, really in-depth diary analysis of household use and management of water. And a lot of insights are coming out, which will be extremely useful to applying to, generating new ways to consider how to manage the water resource. So we are analyzing the broader social issues, the actors who are involved, and the resources and how they shape women's agency in water management and governance. So just to conclude, I just want to throw a couple of things at you here. And very briefly, there's the issue of data and monitoring. And one of the questions that we really have in our region is we don't have long-term data in many cases. So how do you manage, how do you, package your data in order to give useful information to managers? That's a question for you to think about. We need to enhance our technical capabilities and to integrate data that is available, for example, from satellites and other, globally available data sets, and we synthesize this information and carry out modeling at scale, at the scales that are relevant to the people on the ground. One of the areas that I think we can really take advantage of, and this is particularly, for example, in operations and maintenance, is to take advantage of advances in, ICT, artificial intelligence, and machine learning to be able to improve the maintenance. As I had 2 or 3 days ago from a conference in where UNICEF was presenting, they mentioned that in fact, sometimes it is better to use a lot more money to install robust water supply systems than to use cheaper water supply systems, because the more expensive and robust water supply systems are resilient to climate variability and the extremes that come with climate, and along with other factors. So all operations and maintenance issues are reduced. Adaptive management is also important because we have to consider scenarios. We have areas, in one particular area, you can have both flood and drought. And under climate change, these extremes are going to get worse. And so we really need to consider these aspects, as well as also bring in participatory scenarios where we have the local communities also participating in understanding how their futures could turn out given the major changes that are taking place across the globe. Finally, I want to finish off with the fact that we need to have STEAM-oriented capacities. We have a big emphasis on STEM, science, technology, engineering, and mathematics. But we argue that the arts have a major role to play if you want to have a holistic management of our groundwater resources, particularly in these dryland regions, which are challenging not only from a physical and biological point of view, but also from a societal point of view. Thank you.
Thank you very much, Daniel, for sharing this very interesting presentation and for raising some very challenging questions that I'm sure that both the students and the instructors that will watch the video will have fun in answering. So once again, thank you for being with us.
Thank you. It's been my pleasure. Thank you.